again. We would like to welcome all the schools that have joined. Thank you so much for joining. I have muted everyone, and in case you want to say something, kindly you raise up the hand and then you say something. Allow me now to welcome our facilitator for today's session, Mr. S.4. Kindly take over and lead us in today's session. You are most welcome, Teacher S.4.
Okay, thank you so much, Mr. Kaziva, for this opportunity. I once again welcome every school and everybody who is on this call for today's session. And let me reintroduce myself. My name is S.4 Ronald, a teacher of physics and mathematics, and from St. Paul and Pauline's Senior Secondary School, Masaka. Take this opportunity again to thank Help Platform and the Help Fraternity for giving me this opportunity of leading you in this facilitation and giving us this opportunity to add something to the country and to the world in terms of academics. The Help Platform has been so great for us since we joined it. So far for me, I have been using this platform to instill confidence in my learners for almost 3 years. Because I remember I joined the platform of online studies via Help that was after COVID-19 when the schools were opened. And I really thank Mr. Kaziva for everything and every arrangement that he does to make sure that all the sessions which are carried on online are really successful. For real, I can bear a testimony that the Help programs have really done great to our learners. And I will ensure every learner who is here and every teacher who is here that you are not just wasting time to be in these sessions. You are not just wasting time to be there in your school. You are not wasting time to be playing, but this time which you are spending here really contributes a lot to your academic success. And not only academic success, but also your levels of confidence in this world and learning really will be improved and will improve automatically. Because this is a platform that enables everyone to get information from everywhere. It doesn't limit one's source. A learner can get from everyone. Just imagine I'm in Masaka, but someone from Kasese is on this call. Someone from Lira is on this call. Someone from Kabale is on this call, but me, I'm in Central. Someone else from the Central is on this call. Someone else everywhere, even abroad, are here because the Zoom does not limit as long as they have the passport and all the rights to enable them be on this call can join us. This platform has a lot of teachers, many of them, the experienced ones, those ones who are in making, those ones who have just started their profession. So it doesn't limit. Whether you know, whether you don't know, you will know. Whether you learned or you have never learned, you will learn. So please, everyone now who is there in your classroom, who is there in your dormitories, I can see some members in dormitories. Please, thank you so much. Thank you so much for that love of studying and of learning. So for today, we are going to be in physics. We are going to be in physics. It is going to run up to around 6. And we are going to put more emphasis on physics paper 1. That is according to the the new lower secondary curriculum, physics has two papers. That is paper one with the theory, and anyway, there are three, but the two papers are for practical. That is paper two and paper three are for practical, which are done by some school, by the choice of the schools. So we are going to put more emphasis on paper one, that is the theory part. So that is it. So as we are going to be in our session, I'm going to make it interactive. I'm not going to be dictating like that everything comes from me. No, that everything is not going to be from me, but everything that is going to be discussed here, even learners are going to contribute, even teachers are going to contribute. But I would like more to be learners' contribution. Yes, the teachers will be there controlling the learners as they respond. So that is it. That is how it is going to be. So as we are going to go through our session, we are going to be giving rights to people to unmute and they respond. If you don't unmute and if you are not given a chance to unmute and talk to us, we shall just use the chat box. So if you have a response to a given scenario or a given conversation in which we are talking about, please, you are free to chat with us. You are free to chat with us. You are free to chat with us. Sure. So in case of anything that has disturbed you, maybe network, please don't worry. The network's always disturbed, but I think everyone will be stable from where they are. Now, allow me to share my screen. Allow me to share my screen with the questions which we are going to pass through during this facilitation. And let me hope everybody is able to see what is that. This PDF has been shared on the help platform. That platform is most composed of the members who are teachers, and I think they have given them to you. But even if they have not yet given them to you as learners, please, you are going to follow. You are not going to miss anything. So that is our share for today. So before going into the questions, before going into the scenarios, before going into the content of physics, which we are going to deal with today, allow me to talk about the nature of the physics paper, that is paper one. Physics paper of the new lower secondary curriculum, it is of paper code Let's go. It is of paper code 535/1. So as you see, this one, 535/1, that is paper one physics. And its duration is 2.5 hours. So in your final exams this year, that is October, November, you will sit in physics paper one for 2.5 hours. And during that time, you will, oh, sorry for this. Let me reshare again. There has been some problem, but it has come. You will be required to do that. Those will be 5 questions. The 5 questions are in 2 sections. So the physics paper is composed of 2 sections. That is section A, which is compulsory. Section A is compulsory. So please, as you are planning for that physics paper, the section A is compulsory. Then section B, it has two parts. It has part 1 and part 2. In part 1, you will be required to answer any one question. In part 1 of section B, you will be required to answer any one question, that is one item. And in part 2 also, you will be required to answer one item. So in that, let us look at the construct of this paper. In section A will be comprised of 3 items. That is item 1, item 2, and item 3. In simple terms, question number 1, question number 2, and question number 3. In those questions, they don't have specific topic that this question has been gotten from a single topic. No. Sorry. Let me share again. They merged or they combined the topics from where those items are going to be extracted. So with item number 1, item number 2, and item number 3, with item number 1, the topics which, or the elements of construct that will take that, the general topics anyway, let us call them the elements of construct in item number 1, that will be light and waves. So expect a question of item number 1 to be composed of information about light and about waves. That a learner, when you are asked, you will be required to give information or to write your responses which are about light and waves. Don't worry, the way they will be asking you, or the way they will set that item, it will just bring the information which encompasses both, that a scenario which is set will be encompassing both light and waves, as we are going to see. So in light and waves, as you remember, it will be nature of light, reflection of light at curved surfaces, reflection of light, dispersion and color, then lenses and optical instruments, that is part of light that will be in item 1. Then if we go to waves, it will be general wave properties and sound waves. So expect the item, the scenario item of item 1 to be having a combination of information from light and information from waves. So as you are planning to attempt item 1, it is not even planning to attempt it, but it is compulsory. So as you go to your paper, please be ready to be answering, to find item 1 as extracted from light and waves. So as a learner, you will plan appropriately to have the information about light and waves, such that when you are responding to item number 1, you respond it fully. Because if you go there with only light, you will not be able to answer to answer it fully. If you go there with waves only, you will not be able to answer it fully. So it means that for you to answer item 1, you will be required to be with the knowledge of light and the knowledge of waves. If we go to item number 2, that is atomic physics and nuclear physics. Both the information of these 2 branches, the atomic physics and the nuclear physics, you will find I'm really sorry to those people who are annotating. Please, if someone is annotating, just help me and don't. Because when you annotate, if you annotate, you disturb our our document. Those ones who are annotating, please undo your annotation. You go to annotation and undo the annotation because it is really disturbing us. Those ones who are annotating, please don't. Then, if we go to item number 2, that is atomic and nuclear physics. Atomic and nuclear physics, that is, it will be having atomic models and nuclear processes. Atomic models and nuclear processes. So the atomic models and nuclear processes will encompass, it will encompass item number 2. Item number 2. Then, if we go to item number 3, that is Earth and space physics and digital electronics. So, for you to answer item number 3, you will be required to be with information about Earth and space physics and also digital electronics. So, going there with only Earth and space physics will limit you to finish that item, to answer it completely. So if you were to answer item number 3 completely, you have to be with knowledge about Earth and space physics, then digital electronics. In that item number 3, we expect topics like the solar system, stars and galaxies, satellites and communication, and digital electronics. So in that one will be the components. Those ones will be the component topics of item number 3. Then, if we go to section B, in section B, there are 2 parts. That is part 1 and then part 2. With the part 1, it will be, in part 1, there will be 2 items. That is item number, it has to be item 4 and 5. Here, there is a mistake here in typing. It had to be item 4 and 5. So item 4 and 5 will be having mechanics and heat. 2 items from mechanics and heat. So in mechanics and heat, if you want to do for
Mr.
section...
S.4.
Yes, sir.
Yes, kindly go up there on your view options.
Yes.
And then, like when you are sharing, and then you
Yes.
disable annotation.
Okay, thank you, sir. Okay, thank you. I have done it, sir. So thank you so much, Mr. Kaziba, for that. I've been on part 1 of section B. So from part 1 of section B, we expect you to find there 2 items. That is item 4 and item 5. As it is here, it was written item 3 and item 4, but it is a mistake. It had to be item 4 and 5. In that, the areas, it is mechanics and heat. So as you are going to answer the section B part 1 of section B, you will find there items which encompass both mechanics and heat. The information about them will be extracted from the topics of mechanics and the topics of heat. So in that, for part 1 of section B, you will find information. You will be required to answer information about measurements in physics, states of matter, effects of forces, work, energy and power, turning effect of forces, center of gravity and stability, pressure in solids and fluids, then mechanical properties of materials and Hooke's law, linear and nonlinear motion. So those topics are in mechanics. Then the topics of heat transfer, expansion and contraction of solids, liquids and gases, then heat quantities and vapors. That one will be the 3 topics of heat. So expect and those two items of part 1 of section B to be requiring you to answer both mechanics and heat. So as you go to the paper, as you were to answer section B, selecting any one item from it, you in your mind, you have to know that you will be answering about mechanics and heat. It will be of a great advantage to be with the information of both parts, the information of mechanics and the information of heat. Someone going into a paper with only mechanics, it means that you will not answer questions of the first part of section B fully, because they will require you to also answer the side of heat. And also, you cannot go there with only heat. You have to be with mechanics. That is it. So as you are doing your revision, as you are doing your practice, as you are gaining the skills, as you are gaining the values, as you are gaining knowledge, values, skills, you have to get to know that in physics, you cannot gain only skills from one part. As you are preparing for your examination, you will not be required to only be with values and knowledge from one part, because every part that is every part or every item will be comprised of two parts. That is two topics. Anyway, in general, that is two branches of physics. Let me generalize it like that, because these are branches of physics. So entering section B, get to know that you will find there mechanics and heat. That is part 1. With two items, you answer 1. Then the second part of section B, you will also be required to attempt any one item. So as you are attempting any one item from those two of part 2, that is item 6 and item 7, those questions will be extracted from electricity and magnetism. Those two branches, electricity and magnetism. So as you are going for part 2, get to know that you have to be with the knowledge, skills, values of electricity and the knowledge, skills, of values of magnetism. So as you are preparing, don't only prepare for one topic. Don't only prepare for one part. You always prepare accordingly and get to know that everything that we study in physics from senior 1, as you can see, as we were breaking up these topics, we saw that everything from senior 1 up to senior 4, all the topics are taught and all the topics are examined. So all the topics which are in the physics syllabus book have to be examined, as you have seen. It is not like the other time that some parts were left and they could set some other parts. You could find just a question which is only encompassing mechanics, and that is it all. And the learner could just do a question about mechanics and there you go. You find a question about modern physics, just only modern physics, and there you go. Find a question about heat, but for this case, you have to be with skills, knowledge from both sides. That is it. So that is the structure of the physics paper 1, the theory part. But from the last part of section B, I had not gone through the topics. That is the topics which are expected there, or which have to be there they are magnets and the magnetic fields, electromagnetic effects, electrostatics, introduction to current electricity, voltage resistance and Ohm's law, then electric energy distribution and consumption. That is how the physics paper theory is expected to appear. And not, if we say expected to appear, it is like as if it will not appear like that, but it will appear like that. Let it be just spoken like that, that the physics paper will appear like that. They said 7 items from those 7 items. The section A, which has 3 items, is compulsory. Those 3 items are compulsory. Then the section B, which has 4 items, you do 2 items. But each item, one item has to come from one part, and the other item has to come from one part. So it means that section B, you answer one item from each, at least one item from each section. That is one item from each part. That is it. So making a total of 5 items to be answered in the 2.5 hours. That is it. Then, with today's session, what we are going to do is to go through part per part from the selected questions. Yes, we selected the questions, but if someone has anything else to ask, they will be required to ask. They will be given a chance to ask. Even if it is out of a given question which we have discussed, that is it. Even if it is from a given question, even if it is from a given question which we have discussed, or from another question, or from another part which is not from that question, it is fine. But according to the time which we have, we are going to be concentrating on the questions, concentrating more on the questions which we have just selected. Then, since it is not time for paper 2 or 3, but let me just talk about it. This part, physics 535/3 and 4, the paper code for paper 2 or paper 3. That one will be having 2 items. Those 2 items, you attempt only 1 item. So from that 1 item, from those 2 items, expect them to be set from the 3 topics. That is mechanics, then optics, and electricity. Those 3, they set from those 3. But from those 3, expect a question from either mechanics or optics, or from either mechanics or electricity, or from optics and electricity. As simple as that. So from those 2 items which they will be setting, you will be attempting only 1 item. So that 1 item will be done in 2 hours. That is the duration for paper 2 and 3, not 3 and 4. I'm sorry for this mistake. For the error which is here, it is paper 3 and 4 and 2, paper 2 and 3, not paper 3 and 4. Sorry for this typing error, this one. It has to be paper 2 and 3. That is it. Then, as we are going to concentrate, we are going to be in parts of light and waves. That is it. Atomic and nuclear physics, we are going to be there. Then we are going to talk about digital electronics. We are going to be in mechanics and heat. Then also electricity and magnetism. Then from there, if time allows, we shall finish at least a question from each part. And also with the digital electronics, if time allows, I will expound more about the logic gates, the 5 logic gates, and the combination of those 5 logic gates. I will expound more if time allows. So, members on this platform, allow us to start on with our seminar, and let us start with the item from light and waves. From light and waves, I selected this because it was, anyway, according to my choice and the way it is set, it is quite clear. It expounds good knowledge and information about light and waves. So what we are going to first look at is the way it is set to be getting both the information from both parts, the light part and the waves part. So as we are doing this, we are going to go through and we see how a question can be set, or how an item can be set such that its scenario brings out the knowledge of light and waves. So here we move. So from your classes, if you are if you can see clearly, let me try to zoom further such that the font is clearly seen. Let me hope everyone can clearly see that as we read, but it will also depend on the projection of that side, but this is it. So as we move, maybe from your classes, you can be helping me to also read with me, but let's go. Don't unmute. So we go. A war erupted in a certain mountainous area surrounded by small water bodies, where soldiers only communicated by throwing a stone in water to alert their colleagues of danger ahead. But this alerted their enemies. One of the soldiers had small sizable plain millers and a torn paper box in his bag. Their leader sent spies to peep behind hills to see where the enemies were hiding, but many spies were captured and killed. They totally lacked the knowledge on how to solve this problem. The enemy troops had a radio call that was used for telecommunication, and waveforms were produced on the receiver's computer clearly. One afternoon, it threatened to rain, and bright colors of different kind spread in skies. This scared the soldiers more. Full stop. So the hint is there. A graph obtained from the receiver's computer. So this is the graph. Now, as you can see this scenario, a war erupted in a certain mountainous area, surrounded by small water bodies where soldiers only communicated by throwing a stone in water to alert their colleagues of danger ahead. But this alerted their enemies. One of the soldiers had small sizable plain millers and a torn paper box in his bag. Their leader sent spies to peep behind hills to see where the enemies were hiding, but many spies were captured and killed. They totally lacked the knowledge on how to solve this problem. The enemy troops had a radio call that was used for communication, and waveforms were produced on the receiver's computer clearly. One afternoon, it threatened to rain, and bright colors of different kind spread in skies. This scared the soldiers more. Then they gave us a hint, a graph obtained from the receiver's computer. Then they gave us that graph. That graph is of amplitude in meters against the time in seconds. So as a learner, if you can see clearly from the chat box, we can just look at how can you, the way this scenario brings out the information about light and waves before even going to the requirements of the question of the scenario. Do you see there the element of light and waves? If you can see the element of light and waves, then it means that you are on a good, or the question is in line with what has to be set in light and waves, as it is in the paper. So, if you look clearly, there is some information about one of the soldiers had small sizable plain millers and torn paper box in his bag, bringing out something like about the plain millers. I think from senior one work, if some were not late to cover it in senior two, that is reflection in plain millers, in plain surfaces, you can see that the plain mirrors are there, that is light, the party of light. Then also someone talking about the colors of different kind spreading in the sky. So it is also information about light. Colors of different kind. Colors of different kind spread in the skies. That one is also something that tells you that that scenario has information about light. Then, if we go to the way the enemy troops were communicating, they are saying that the enemy troops had a radio call that was used for communication, and waveforms were produced on the receiver's computer. So being that there is waveforms which were produced on the receiver's computer, then it means that this scenario has information which is required from light and waves. So please, and also in the hint, they gave us a graph obtained from the receiver's computer. If someone just talks about amplitude, the amplitude of a wave, anyway, let me just say the amplitude. If you just say amplitude against time, I think everyone's knowledge just goes to a waveform. Amplitude waves. Watch it again. Amplitude waves. I'm sorry for that. It has gone through. Someone has not gotten it well, but it's fine. So someone talking about amplitude, that is fine. Then someone talking about amplitude, it is waves. So someone looking at this graph as it is a waveform. So in that, it means that you as a learner, if you came in a paper finding such a question, if you don't know something about light and something about waves, then if you did not read about light and waves and find the other scenario which you have covered, yet they said that in section A, everything is compulsory, then it means that you will not be able to respond to that if you did not get skills in light, if you did not get the knowledge in light, if you did not get the understanding in light. So please, as we are doing this, it has to be like that. Then if we go to the requirements of the question, the task is, as a physics student, help the soldiers to understand why throwing the stone in water always alerted their enemies. Now, this goes to everyone on this platform to think about that. From everywhere you are, according to the knowledge of light, of light and waves, please may you help the soldiers to understand why throwing the stones in water always alerted their enemies, because their objective was not to alert the enemies. They said, if we start from here, where soldiers only communicated by throwing a stone in water to alert their colleagues of danger ahead. These soldiers wanted to alert the soldiers wanted to alert their colleagues of the danger ahead, but this alerted the enemies. Throwing the stone in water, they wanted to throw the stone in water to alert their colleagues, but that one alerted the enemies also. So from there, a question comes to, or anyway, a requirement comes to you to, as someone who understands physics, understanding the physics of light and waves, to help the soldiers understand why throwing the stone in water always alerted the enemies. So from there, just take a simple discussion with your friend. Why do you think throwing the stone in water always alerted the enemies? always alerted the enemies. Why do you think? So let me stop the share and we go, if we go to the chat box, let us go to chat and we see. The voice is very low. Oh, Lord, let me first increase it. If the voice is very low, let me first test it here. Let me first look at the speakers here. If the voice is very low. Am I now clear? Let me look at the.
Yes, you are clear.
Clear. Okay, that's good. That's good. So if we go to the chat, let me hope that time for me checking my microphone is audibility. I think someone has thought of why throwing the water, the stones in the water alerted the enemies. Why do you think so? If someone can raise up the hand, or and we give you some, let me just look into the chat. Look at what they have. The participants have raised the hands. Okay, from, is it St. Leonard's SS? I see you there with your hand. Please, St. Leonard's, may you unmute and respond. St. Leonard SS. May you please unmute St. Leonard's SS and respond. Yes, Leonard. Okay, let me talk to, that is St. Leonard. We are not getting him because he is not unmuting himself. Let me go to Gombe High. Gombe High School, may you please unmute and respond to that, and then we go. Give us your view.
When the stone was thrown in water,
Yes.
the water body was vibrated and
First, wait, please. Let me first ask the people in the background of Gombe High School, Kawala, not to bring the noise. Yes, Gombe High School, Kawala, we are with you. Please, may you speak again because your background was disturbing. Gombe High?
No, I don't know. Lower
Like
high.
throwing
Yes, go.
throwing the stone
Yes.
in water.
Mm.
It was like a source of disturbance that made waves to move, forming sound waves
Yes.
on water.
Yes. Okay, thank you so much for that response. She says that throwing the stone in the water, it was a form of a disturbance. And remember, whenever there is a disturbance in a given medium, that is formation of a wave. So I think alerting the enemies was due to both the sound waves from the disturbed water, because you cannot throw a stone in water and it doesn't produce sound. Then also, you talk about water waves, which are created by the stone. Remember, someone is speaking. Remember, these soldiers were just hidden from enemies, anyway, from both sides, because they were attacking each other. So, as these ones were communicating to their fellows, what they didn't know was that if you throw a stone in water, there are two disturbances you make. Those two waves, the water waves will clearly indicate that there is something which has happened in the water. And also the sound of the water waves, the sound waves from the disturbed water So as you are explaining to that, as you are responding to that, your direction should be to the disturbance that is made by the stone. So I thank someone who has given us that response. Please, thank you so much from Gombe High. As we go to something else, let me hope everyone can respond to that, because as you are helping them, so as you are to help these soldiers, explain it to them. Please, as you are explaining to them, please let them understand that throwing the stone in water creates a disturbance in water, which is a wave. So the enemies will see that wave, and also throwing the stone in water creates a sound wave, which will be heard by the enemies, that there is someone who has caused the sound of the water. So that is it. Now, if we go to the second requirement of this question, to the second task, it is, as a physics student, help the soldiers to understand the best way there is an error there, because you cannot say to the best way. It could be understand the best way. To understand the best way, please put understand there as you are correcting. To understand the best way, they could reduce the rate at which their spies were being captured. The best way, they could reduce the rate at which their spies were being captured. Remember, as we go to the requirement of the question, to the scenario of this question, it is that, let me just do this. It is that, their leader their leader sent the spies to people behind the hills to see where the enemies were hiding. But many spies were captured and killed. So the requirement is telling us to help the soldiers understand the best way they can reduce their spies from being killed or from being captured. So according to this scenario, how do you think that these soldiers could reduce the way their spies were captured? Because every spy who were sent there, they were captured and killed. Now, if you are the leader of those soldiers, may you please send other spies to be captured and killed, or you just devise a means of reducing how they could be to reduce the rate at which they are captured, please. But as you are explaining that, you are going to use the knowledge of light and waves. So from there where you are, which advice or what can you tell these soldiers, that what should they do to reduce the rate at which the soldier, their spies were captured? So first think about it. It is a 30-second time. You think about what should they do. If we go through this scenario, a war erupted, certain mountain area, surrounded by small water bodies, where soldiers only communicated by throwing stones in water to alert their colleagues of danger. But this alerted their enemies. Then they go. One of the soldiers had small sizable plain mirrors and a tiny paper box in his bag. So their leader sent spies. That one we have seen it. So they totally lacked knowledge on how to solve this problem, the problem of their spies being captured. So please, as a learner of physics who has read through this scenario, How do you think these soldiers could reduce? How do you think they could reduce being captured? So let me look at the people who have raised their hands. Then we have Premier High School Kanoni. Premier High School Kanoni, may you please unmute and respond to that and see how they can reduce? Please. Okay, you can unmute, and first wait. There is some noise from your background. I don't know how many gadgets do you have there, but if there is any second phone or something which is, or an NS which is facing your microphone.
The soldiers have some piece of paper and mirror. They should use them to make a periscope, which is used in water and in corner.
So he says that they should use the mirrors and the paper to make a periscope. Thank you so much for that, which can enable them to peep over to see the enemy. Let me also look at someone from, that is, let me see. There is Maji Seed School in Ajumani. From Ajumani, Maji Seed School, I am seeing your hand. May you please respond to that? May you unmute and respond? Maji Seed School. Maji Seed SS Ajumani. Are you there? Okay, Maji is not. Then do we have, let us look at Serere Secondary School. Serere Secondary School, may you unmute and please respond to that in your view, or even if it is clear with that, then you tell us, and we just leave. You just be active, that your view has been like that of the previous contributor. Serere Seed, Serere Secondary School, not Seed. Serere Secondary School. Okay, let me also look at below parents. Below parents, may you please unmute and respond to that? Yes, below?
They will use the knowledge of the periscope, the knowledge of
the knowledge of a periscope. What else?
they use the knowledge of reflection, that they get the boxes and then they make a periscope, of which they will use to look behind the fields.
Okay,
secondly,
thank you so much. Secondly,
I will say that they are slowing small stones in the water body. They will stop slowing the stones in the water body so that the sound waves are again, that they will be cold. That's it.
Okay, thank you so much. Yes, he has given another contribution that these soldiers should stop throwing stones to the water, because the stones produce sound waves which alert the enemy. That is it. Thank you so much. But please allow me, as we proceed, before going away from this, from this, let me just do, sorry, don't ask me, okay? I'm sorry for this. Just share something about a periscope, and we see how they can devise the means they have to make that simple periscope, and how a periscope is used to solve the other problem of not being captured. Now, let's look at this. Let me share something here. Okay. Let me stop share. Let me do this. There this. Okay. As if there is some problem about my sharing, but I wanted to share something about the periscope and how a periscope can be, anyway, the periscope to be clear to those ones who have never seen it, and how they can use the paper boxes and the mirrors they have to make a simple periscope. But my sharing, anyway, let me do this. This is not coming out well. Let me first stop the share. Just do something from here. Just remove this. Okay, I think this one will be clear for us if you share it again. Okay, that is it. So I thank God that we have you have gotten it. So here is my simple periscope. So I just created some illustration is whenever they could be required, but this is a simple periscope. This one, this is a simple periscope, and how they could design it. The flame of the periscope is made by the paper boxes which one of the soldiers has. So in that, I think if you are not, if you got time during reflection of light on plane surfaces, some of you made a project, or we are required to do a project of making a simple periscope from paper boxes and plane mirrors. So this is a reflecting periscope. Now, what I did here is to show you how it can be used. If the enemy is located from this point, and this is a barrier, this one. If this is a barrier, and for you, you are located here, in this location, these soldiers, let me say the soldiers, not you, but the soldiers. So the enemy is this side, there is a barrier. If you just use direct vision, you will not be able, because there is a barrier which is opaque from the rectilinear propagation of light, that light travels in a straight line. You will not be able to see the enemy when the barrier is here. But with the use of the simple reflecting periscope, you can peep and see the enemy, because the periscope gives you room to see something which is behind an opaque barrier, like that. So the soldiers could just make a periscope, and then they peep from a side from where they cannot be seen by their enemy. So as the spies were sent, if they were sent by the periscopes, they could not be captured, because the enemies could not see them, because the periscope enables the soldiers to see their enemy when they are in a hideout. So that is all about a simple periscope. A simple periscope from the box making a flame, and the plane mirrors which are mounted at an angle, at angles from the vertices of the periscope. So that is it about that. So using a simple periscope, which can be designed using small sizable plane mirrors and a paper box to help the spies peep the enemy. So let me stop this share, and we go back to what I had shared and we go back about to the questions of this session. The questions of this session, that is facilitation questions, yeah. So if we go back to what we have shared, we are set to discuss for today, then okay, then we go back to our scenario. Then the second part, the next part says that as a physics student, help the soldiers to understand the strange appearance of the skies that sent them to hideouts. Remember, when these from, let me just reduce the, okay. The task says that as a physics student, help the soldiers to determine to understand the strange appearance of the skies that sent them to hideouts. Remember, as these soldiers were in their battle, one afternoon it threatened to rain, and bright colors of different kinds spread in skies. This scared the soldiers. Just imagine how how the soldiers could just see the light, the lights in the sky, and they just go run and hide, as if there is something strange. They saw something strange they didn't know. As it was threatening to rain, then bright colors spread of different kind spread in the sky, and they were scared. Then the scenario, the item, the requirement of the task says that after being scared, they went to hideouts. They were scared of the colors. So please, as a physics learner who has the knowledge of light and waves, help these soldiers to understand the strange appearance of the skies that sent them to hideouts. So please, those who are there, what do you think could be a great advice or a great explanation to these people? A great explanation to these soldiers, such that they don't go to hide because they were scared of the colors which were spread. So what should you explain to them such that they don't get scared again? From the chat box, yes, seeing some participants raising their hand. Let me hope they are in line with us. So what do you think? Let me just run down here. If I look what, this is Leonard, I gave you there is, Premier, I gave you attended Jackson, is a school, we are doing Gombe High, there is a Vanessa here. Let me look what, there is Patong Seed Secondary School. May you please unmute and respond to that. Patong Seed Secondary School. May you please unmute and respond to that. What could you explain to these soldiers?
Yes, according to the knowledge of the physics that I have,
Yes.
the formation of the colors in the sky is just because of when the light ray passes through the raindrops, it splits and forms certain colors in the sky. That one is rainbow.
Thank you so much. He says that the sunlight passes through. Let me mute you. So he says that according to his knowledge of physics, that when light passes through the drops the drops of rain in the sky, it spreads, and it spreads into colors, which is the rainbow. Thank you so much for that contribution. Let me also give a chance to Lugashali Parents SS Kagadi District to unmute and respond to that. Lugashali Parents, may you please unmute Lugashali if you are there. Okay, Lugashali is not unmuting. Let's go to Jericho High School. Jericho High School, may you get this chance to unmute and talk to the people who are here, give them your view. Jericho High School.
This was due to the dispersion of white light which passed through the rainbow, resulting into the fear caused by.
May you please be clear. The light passed through what? Passed through the rainbow. The what? The rainbow.
The rainbow.
The rain.
The rainbow.
Okay.
This was due to the dispersion of white light which passed through the rainbow. Which passed through the rain droplets.
That is Thank you so much. There was clarity in your explanation, but thank God that you have cleared it. That because of sunlight pass. Hello. Let me mute you. Because of the sunlight that passes through the rainy droplets, remember the scenario says that one afternoon it threatened to rain and bright colors of different kind spread in the sky. Threatening it rain, it means that it was like going to rain, but it didn't rain. And then after threatening it rain, it means that there was droplets. If we don't say humidity, is it? Geography people, the droplets in the sky, is it in line with the humidity? I think it can be possible if I put it in line with that. So the droplets which are in the sky, if the sunlight passing through the sky, there will be dispersion of that sunlight. Remember, sunlight is white light. Remember, sunlight is white light. So that white light, whenever white light passes through either the liquids, a transparent liquid, that is water, and in a glass prism, it will be dispersed. That is, it will be spread into its constituent colors. Remember the constituent colors of white light? Those colors which make the ordinary rainbow, but in physics, it is the spectrum. So the spectrum will be formed when white light or when sunlight is being dispersed. To those people who have never who have never done dispersion of light, but I think this experience from the years you've studied from, I think you started using pens from P2 to senior 4. Was it P3 to senior 4? Or if others started using their pens in baby, let me hope so. When you use a pen, when your pen is in sunlight, there is some colors of the rainbow which are cast in the pages of your books. Please let me hope everybody has ever seen that. If you have never covered the dispersion of light, so that sunlight, the colors of the rainbow being seen from your paper when your pen is in sunlight, it means that that pen has split the white light into its color components, because white light has many colors in it. So since white light has many colors in it, as it is passing through the pen, it will be spread into those colors that makes it. That is a rainbow being formed by the pen on the pages of the paper. If you have ever written from the sunshine, then that one also occurs. It is the cause that makes rainbows to be seen in the sky. When light finds water droplets in the atmosphere or in the sky, then the water droplets will split it into the colors which are the components of the white light. So then dispersion will occur. Dispersion is splitting of white light into the components. So as you are explaining it to these soldiers, you have to tell them that please don't run. Those are not demons. Don't run, those are not demons. They are just because it threatened to rain. So as it threatens to rain, then the sunlight is split into those colors. No one is bewitching you. They may have run into hideouts because they could think of their enemy bewitching them. But please just help them to come out of their hideouts and devise the means of fighting the enemies, not to be scared of the what? Of the lights. Then if we go to the last requirement of this scenario, determine the frequency at which the waves reached the receiver at the home base of the enemy. Remember from the scenario from here, the enemy troops had a radio call that was used for communication, and waveforms were produced on the receiver's computer clearly. Please, you, the person who understands physics, may you help the soldiers to determine the frequency at which the waves reached the receiver at the home base of the enemy. Now, our emphasis should be put on the waveform. Let me just dictate about that. On this waveform, for us, if we are to determine the frequency at which the waves reached the receiver at the home base. Now, that one needs a calculation. The skills you gained in waves. So we looked at, we've seen the first requirement was in waves, the second requirement was in light, the third requirement was in light, and part D has taken us back to the waves, determining the frequency. So from there in your classroom or from your dormitory, may you please first look at this waveform. If it is just 2 seconds, no, not 2 seconds, but 10 seconds, how do you think we are going to determine the frequency at which the waves reach the receiver at the home base? Look at that, the waveform. Let me just zoom it such that we can see it clearly from your projection, your areas of projection. So that waveform, how are we going to determine the frequency? That is just a discussion from where you are with your friend. Hey, I'm not going to ask people to raise their hands, but I think it is going to be after discussion, then you raise your hand. After discussion, then you raise your hand. You look at that. Amplitude against time. This is time, then this is amplitude. Then the frequency. How are we going to get the frequency? So if you hear some background, I'm also with my learners this side discussing, but they are not as such loud. Yes. So how can we get the frequency? Then let us go to the chat, to the participants who have raised their hand. The participants who have raised their hand to give us their responses, their contribution. The participants, let me look at, anyway, I don't know. Hello, please, in the background, don't be so loud. Please, I don't know whether some schools have just used the individual names, but I just wanted to be engaging these learners who are at school. Anyway, I'm giving chances to schools. I'm sorry to the people who have entered the meeting with individual names, like I'm sorry, Hajara, I'm sorry, Nsana Habati, I'm sorry, is it Nzana? Habati, I'm sorry, Chisache, I'm sorry for that. Yes, I'm just looking at these schools. There is, let me just look at Katale Kamese. Yes, Katale Kamese Modern SS. Then after Katale Kamese Modern SS, may you please unmute. May you please unmute and respond to us? Katale Kamese. Yes.
You get frequency is equal to number of cycles divided by frequency is equal to number of cycles, complete number of cycles divided by time taken.
Frequency equals
whereby the number of cycles divided by time, number of complete cycles.
Yes. Divided by the
time taken.
Thank you so much. So if you look at our share there, the number of complete cycles from if you are there, Katalika message still be there, remain on call. Don't worry, I'm still with you. How many complete cycles are there?
2.
How many
there are 2 complete cycles.
Yes, please.
2. There are 2 complete cycles.
There are 2 complete cycles.
Yes.
Then how long has it taken for them to be completed?
It's 8.
It is 8
seconds.
Okay, thank you so much.
Yes.
But somewhere it is not clear here. Maybe is it clear to that side? Then also here, but it is fine according to the scale which they have used. So it is 8. So 8 seconds, we have said the number of cycles which are 2, not so?
Yes.
Then divided by the time taken, that is 8, not so?
Yes.
Then you get the frequency. Thank you so much. From the other definition of frequency. Thank you so much. So what frequency have you gotten, Katalika message?
Yes, it is 0.25.
Is 0.25. With the units, please don't forget them. The unit has. Thank you so much. May you please mute. And we get another contribution. That is how he has gotten it from the number of complete oscillations divided by the time taken to complete those oscillations. Let me go back to my people. Let me look at Central College Kawala, St. Kizito High School, Bethany. I'm there. St. Kizito High School, Bethany. May you please unmute? St. Kizito, unmute, please, and respond to that. That is his own way. Then please respond to us also.
Can I show you my answer?
Okay, let me just give you the right here, but you will talk about let me, okay, let me just look at the rights here. Okay, try to share it. Try to share it.
Okay, the time is equals to. When I count here.
When you count.
This is making a complete oscillation, which is a crest and a trough, whereby it is 4 seconds.
4 seconds, 4 seconds.
Yes. Whereby frequency is equals to 1 over the period that is taken.
So talk about the period. Help us to talk about the period.
One oscillation, it is the period, which is the time taken to complete one oscillation.
Thank you so much for that.
So time is equals to 4 seconds for one oscillation. Then that means that frequency is equals to 1 over time taken. That is 1 over 4, which is equals to 0.25 hertz.
Thank you so much for that. Hey, there we are. We have reached there. So we have gotten 2 contributions and they have enabled us to reach the same answer. To determine the frequency, we have gotten the same frequency, but different contributions. Now, the first one, let me just go to, anyway, let me just annotate from here. Let me just annotate. The first one said that we look at the time axis. We first count the number of oscillations which have been completed in the waveform. So from this point of 0, remember a complete oscillation is when in simple terms, that the particle returns to the original point where you have considered it to be. So if we consider the particle at the mean position in this time axis, it is the mean position. So if we consider it, the particle to be here, as it is vibrating, then the oscillation will be completed at the same time at the same point at 4 seconds. So with this form, we shall not consider it at this point of 2 seconds. It is completed at 4 seconds. So from here to here, that is when a cycle is completed. So as it is completed, please, that is one cycle. Then the second cycle is also completed at this point here. So those are two oscillations. The number of cycles is 2. Then from there, the time taken to complete those cycles, that is the time taken to complete those cycles is, what is that time from 0 along the time axis. Look at the time axis, then it means that it is going to be, according to the scale, this one is not clear here. I'm sorry for that. And also here, but according to the scale, they are just giving us a deviation of 1 second, 1 second, 1 second, 1 second. It means that here we have 7, here we have 8. Here there is 8. So in that, the 2 cycles have been completed in 8 seconds. In 8 seconds. That handwriting, I'm so sorry. Hey, I'm really sorry if I write poorly the unit. So those 8 seconds, then you just get the frequency. Remember, frequency is the number of oscillations completed per second. So if there are 2 oscillations which are completed in 8 seconds, so to get the frequency, you will just get this number of oscillations, which is 2, then divided by the 8 seconds. then you get your frequency as 2 divided by 8, which is 0.25 hertz. That is it. Then her contribution, it was a girl, she was a girl. Her contribution is similar to what I prepared. That's why even I also thought of this. Let me just share it to you. Share it with you like this. So here, we go to, So you first get the period. Remember, the period is the time taken to complete one oscillation. So from the formula of frequency, that frequency is equaling to 1 over period. Period, not just time for the whole oscillation, for the whole waveform, but just to complete one oscillation. So the period, the period is the time to complete one oscillation. And we saw that the one oscillation is completed in 4 seconds. So it means that our frequency will be 1 over 4 seconds, which is 0.25 hertz. That is it. So please, thank you so much for that contribution, for whoever has contributed to this, and to that one who has not actively contributed on call but has done a discussion from there. Those are the ways in which we can determine that the frequency. Then allow me also to proceed to our bulletin. That is physics, the question. That is. So from there, let me reduce on the Zoom like that. Then if we go, may we go to atomic physics according to the time remaining? May we go to digital electronics? May we go to mechanics and heat? May we go to electricity and magnetism? Or we go to, where should we go? Where should we go? Let me go to the chat and see. Where should we go? To those remaining ones. To those remaining ones. Where should we go? Oh, we have not understood. So where should we go? I just want someone to tell us according to the remaining parts, because the time is, if we check here, we have only 27 minutes to complete our time interval, which we had scheduled. Where should we go? I just want it to be in the chat at least. Hey, in the chat. To the chat, people are not giving me. Okay, let me go to the hands. The parts which are remaining, we have. Let me just load. Just load. So we have atomic and nuclear physics. We have digital electronics. We have mechanics and heat. We also have electricity and magnetism. So where should we be? Let me just get someone to respond to us. At least 2 people to confirm that. Okay, let me get it from St. Elizabeth Girls SS. St. Elizabeth Girls SS, may you please unmute and tell us which part can we take? St. Elizabeth?
Electricity and magnetism.
Electricity and magnetism. Thank you so much. Are we all good with electricity and magnetism or anything else? There is also part of digital. Anyway, I was so interested in also going to digital electronics, because digital electronics being that it has been just brought to the new lower secondary curriculum. Many of people may not be familiar to it, but at least we know the principles of the principles of these gates, the principles of the logic gates, but also we can be here in the electricity and magnetism. So in electricity and magnetism, during a science project, okay, electricity and magnetism. Item number 8. Item number 8. A certain household has a set of appliances as listed in the table. So appliance, power rating, then time of use. Then we have the appliances, we have 4 bulbs. The 4 bulbs, each bulb has a power rating of 20 watts each. Then the time of use, the bulbs are used 13 hours every day. Then another appliance, we have a cooker. That cooker has a power rating of 2,500 watts. That cooker is used 4 hours every day. Then also the flat iron has a power rating of 1,500 watts. That is, it is used 5 hours every week. Note that it is every week, not every day. Then there is another electric appliance, which is the electric fence of low resistance wire, which has a power rating of 2,200 watts. The fence is used 10 hours every day. Then, while making the budget, the owner of the household was confused of how much money would be required every week to cater for the electricity bill. He was also confused on how the sockets for the appliances should be connected to ensure that to ensure high current flow, and why low resistance wire is used instead of high resistance wires. The owner intends to spend 50,000 shillings on electricity every week, and each unit of electricity costs 300 shillings. Use the knowledge of physics to, part A, determine if 50,000 shillings would be enough to cater for the electricity bill for the week. Then part B, explain how the sockets of the appliances should be connected to ensure maximum current flows. Then part C, explain why low resistance wires are used for the electric fence. Then part D, suggest the measures on how to reduce the electricity bill. That is the item. Then also item 9 says, because from item 9, we shall get well the requirement of being from electricity and magnetism. This one, requirement 8, I was just interested in it because it has something about, anyway, it brings well some few things which are mostly left whenever teachers are teaching that part, because some of them may leave this part of electric energy distribution and consumption, the distribution of, and then house wiring, distribution of electricity, consumption of electricity. So some of them may, I said some, not all of them. So, but as we are in it, please, I felt it is to be emphasized because it is mostly left, and learners may not get that knowledge of getting it because it is always the last part of electricity. Then with item number 9, during a science project, learners are told that electricity at a substation is transmitted at 13 kilovolts with a current of 0.05 amperes using thin aluminum wires for use inside a house of voltage 200 or voltage of 240 volts. Yes. Let's move. The house has two television sets that operate on a direct current but should be connected such that they receive maximum current and function properly. The learners, however, couldn't get an explanation of the issues mentioned during the science project. Now, these learners were in the science project and they were told that electricity at a substation is transmitted at 13 kilovolts with a current of 0.05 amperes using thick aluminum wires for use inside a house at a voltage of 240 volts. The house has two television sets that operate on direct current but should be connected such that they receive maximum current and function properly. But these learners they did not get an explanation of the issues. They were confused of this explanation. Then use your knowledge of physics to understand how voltage, that is it. But before going there, look at this. Learners are told that electricity at a substation is transmitted at 13 kilovolts with the current of this 0.05 amperes using thick aluminum wires for use inside a house at a voltage of 240 volts. So from just that information, for those ones who have covered electricity and magnetism, you can see that that information just enables just that statement from that learners are told to this, that it encompasses both electricity and magnetism. If we have just thought faster before even going into the details of the requirements of the question, that as there is transmission of electricity, that is current electricity, that is electricity, then magnetism comes from where? Who can tell us where magnetism comes there? Substation is transmitted at 13 kilovolts. Then, using thick aluminum wires for use inside the house at a voltage of 240 volts. Who can tell us where the knowledge of magnetism is in that statement? Let me just check for people from here and tell us, how can you tell that that statement has something about electricity and magnetism? We have seen electricity having volts, having amperes, kilovolts. Now, where should we? We have, there is Central College, there is ACT High School. ACT High School, may you please unmute and tell us, where can we get the knowledge of magnetism in this statement?
We can get the knowledge of magnetism and electricity through the step-down transformers and step-up transformers, sir.
Thank you so much for that. To those ones who have not covered the part of electromagnetic induction, that is, being that, remember, the electricity at a substation is transmitted at 13 kilovolts. These 13 kilovolts, as you transmit it, then in the house, the electricity goes in the anyway, let me just do it like this. The statement says that learners are told that the electricity at a substation is transmitted at 13 kilovolts with a current of 0.05 amperes using thick aluminum wires for use inside a house at 240 volts. So, being that it is transmitted at the substation, it is transmitted at 13 kilovolts, and in the house, it reaches the house at a voltage of 240 volts. There, from someone who has contributed to us, has told us that there is a knowledge of transformers, and the transformer which is used here is the transformer that can reduce this voltage from 13 kilovolts to 240 volts. I think 13 kilovolts is too much higher than 240 volts. Those ones who can just get something from 13 kilovolts. These are 13 kilo. Don't be confused that these are 240 and these are 13. The 13 kilovolts are far greater than the 240 volts. So being that transformer reduces the 13 kilovolts to 240 volts. So that is electromagnetism. So that is electromagnetic induction. So please, as you see this number 9, that is where we can get that knowledge. Then the knowledge of electricity is there. In the question, it says, use your knowledge of physics to understand. There is also some confusion here, because we are explaining, the learners were confused. So it has to be use your knowledge of physics to help the learners to understand how the voltage is changed from 13 kilovolts to 240 volts, from 13 kilovolts to 240 volts. Yeah, it has gotten from there. So how can we tell the learners to understand how the voltage is changed from 13 kilovolts to 240 kilovolts? So just that one who studied the knowledge that can enable us do this. How can you explain to these learners to know how this voltage is changed from this much voltage to this 240? Remember, to those ones who have not interpreted well 13 kilovolts, 13 kilovolts is just 13 kilo. Let me just, oh, my 3. 13 kilovolts is just equaling to 13 times this K, means it is 1,000. So everything which you see with that letter K, a value which has something like 13 kilo, 2 kilo, 2 kilo, something like 2 kilograms, 2 kilovolts. It means that in the 13 kilovolts, we have 13 times 1,000 volts. If it is a kilogram, it is 13 times 1. If it is 2 kilograms, it means that those grams were multiplied by 1,000 to get 2 kilo. So it is 2 times 1,000 to get the number of grams which are equivalent to 2 kilograms. So it means that even here with 13 kilovolts, that is 13 times 1,000 volts. So if you have not yet, if you had gotten some confusion also, that is 13,000 volts. So the 13,000 volts were converted to 240 volts to be used in the house. Now, to someone who has the knowledge of physics, how can you help these learners to understand how the voltage is changed from 13 kilovolts to 240 volts? Responses, please. Just summarizing, explaining what can enable that voltage to be reduced to 240. Let me get some responses from here. Let me look at the people who have raised their hands. Okay, let me get someone from St. Francis de Sales, Iliowa. May you please unmute and respond. St. Francis de Sales, is it de Sales, Iliowa? Yeah, let me hope I have pronounced it very well. Okay.
Thank you, sir.
Welcome.
I think you can use the knowledge of transformer. Use the step-down transformer to transform the voltage, high voltage, low voltage.
Okay, thank you so much. Can mute. That is. So the knowledge of transformers, in transformers, we have two types. There is a type which is a step-up transformer and a step-down transformer. So the step-down transformer reduces voltage from high voltage to low voltage. Then a step-up transformer, it increases from low voltage to high voltage. For example, if I can just give an example, the transformers which are put at the dam, the transformers which are put at the dam before transmission for use, they are step up because they have to make sure that the voltage which is transmitted is high. Then the transformers which are put at the substations for home consumption have to reduce the other voltage to low voltage. So it means that they have to be stepped down transformers to enable them not to harm the houses in which that electricity is going to be used. So thank you so much. That is the knowledge of transformers. So as you are explaining that to the learners, you have to emphasize how a step-down transformer is, what a step-down transformer is, and anyway, even you can also sketch it. Draw a simple structure for a simple sketch for them, such that they know that there is some induction between the two coils that enables it to do what? To reduce the other voltage. That is it. Then part B, summarizing, because time, I see we are having some little minutes. But as we are moving, let us just look at summarizing with that. Then why do you think, no, it is use your knowledge of physics to explain to the learners why you think aluminum wires are used during power transmission. So as you people who are there, why do you think aluminum wires are used during power transmission? When they are transmitting wire, going power, they use thick wires. Why do you think they have to be thick aluminum wires? Some responses from there. Let me just see this one. Anyway, I'm going also to give some. There is this one who is Kanjuchi High School. Kanjuchi High School. Then from Kanjuchi High School, I will give also chance to go this way High School. So Kanjuchi, unmute please and respond. Why do you think they use the thick aluminum wires?
To increase the cross-sectional area and therefore reduce resistance in the copper, in the aluminum wires.
Thank you so much for that. To increase the surface area of the wires. Remember, these wires are big. It is not surface area, but cross-sectional area. From the knowledge which you have about resistance, from the knowledge of resistance, the factors which affect the resistance of any conductor or a wire, there is what they call cross area of cross section. Let me just try to, sorry for that. I'm going to annotate in that such that we get to know about the cross section, the cross-sectional area. Now, as I annotate, let me hope my cable is, the annotation is going to be quite clear. Now, if this is my power cable, how big it is. Let me just draw that end. Just that. So remember, the cross-sectional area in the factors that affect the resistance says that the resistance when the cross-sectional area of the conductor is low, then when it is low, the resistance will be high, and when the cross-sectional area when the cross-sectional area is small, then the resistance will be high. And when the cross-sectional area is big, then the resistance will be big. Then what is that cross-sectional area? The cross-sectional area is just the size of the wire. Let me just, it's simply the size of the wire, but it is, if you were like cutting across that wire, if this wire was cut, if it was continuing to this point, and I just cut it by this point, what is the size of this area? Across the wire. So that is the cross-sectional area. How big is that wire? Cross-section, not surface. So the cross-sectional area affects the resistance. So if it is big, the resistance will be low, and then the power will move with ease. Remember, when the cables are of high resistance, electricity will not move with ease. Remember, resistance is the opposition to the flow of current. So current will not flow well in wires which have high resistance. Thank you so much. Another contribution about that. Another contribution. Let me just look at someone here. I said, it was God's way. The chance is God's way. High school, may you unmute? God's way high school. There is, let me just
As a representative of God's Way High School,
yes.
The answer, as Master you have said, it's about resistance, whereby this one we say that our final answer is thick wires have a high resistance to the flow of current, while thin wires have a low resistance.
The thin wires? Why thick aluminum wires are used during power transmission? Your answer is? Hello? Go this way? Go this way? I think God's way is off the line. Let me just give a chance to Okochia Girls Secondary School. Okochia Girls Secondary School. May you unmute Okochia? Let me hope I have pronounced it very well. Is it Okochia Girls? Okochia Girls? Yes, please.
Okay. As a representative of Church Girls, our answer is like this. Aluminum wires are resistant to heat and good conductors of electricity.
Thank you so much.
In this way that they are not fully resistant, that cannot allow electricity to pass through them. That is our answer.
Okay, the aluminium is a better conductor of electricity. Okay, so its resistance is as in aluminium. Its resistance is low to current. So it means that current will flow easily through aluminium. Thank you so much. Current will flow through aluminium because aluminium has a low resistance to current flow. Thank you so much. Let me also give someone a chance to give us something that is finished. Then there is Wailaka. Wailaka, you have raised the hand. Wailaka Modern SS. May you please unmute and respond. Why do you think thick aluminum wires were used? Wailaka, are you online? Wailaka Modern SS. I think he has. Wailaka? Wailaka model? Oh, Lord. Okay. Let me also give a chance to, that is, Universal College Mubende. Universal College Mubende, can you please unmute? Universal College Mubende. Universal College Mubende, why do you think thick aluminum wires were used to transmit electricity? May you please unmute? Universal College Mubende, are you online? Yes, Universal. We cannot hear you well. The chances may go. Let me look at Mbale Christian High School. Are you there? May you please unmute and respond to that. Mbale Christian High School. Mbale Christian High School. Okay, let me just go to these people who are just, let me just look at, as if I have seen somewhere that is, God is way, Mbale, there is, okay. St. Aloysius College Nyapea. St. Aloysius College Nyapea, may you unmute and respond to that? St. Aloysius. Yes, St. Aloysius. We can't hear you well. Let me just ask someone, am I clear or am I heard? I think I'm heard. Let me just look. Let me ask this one. Selele Secondary School. Let it be that. Let it be your chance, Selele, to talk to us and then we move. Selele Secondary. Selele Secondary School. Can you unmute, please?
Okay. Why there is low resistance? Because first of all, we need to understand that when there is large cross-sectional area, there is less pressure.
Yes.
So since there's less pressure, therefore there's a low resistance. And therefore, that's why we use thick wires than from using what? The thin wires.
Okay, thank you
when
so
we
much.
use thin wires, okay.
You have been confusing.
Okay, please. I said when we use thin wires, there will be higher resistance due to the loss of electrons. The kinetic energy of the electrons.
Thank you so much for that. That your information has been unclear in the first way, but you have brought it clearly that when the cross-sectional area is high, is big, then the electrons will flow clearly. That is low resistance, because where they are flowing, it is something that is large. So the electrons which flow per second through a certain section of a conductor, I think that is carried. So it will be too much with ease when the conductor is big. But when the conductor is very small, then it means that the electrons will flow with difficulty. That is resistance. So imagine when, may I, let me give this example. Now, since we are approaching supper time, but I think it is supper time to some schools. Imagine when the bell rings. Let me first mute it because they are just. So imagine when the bell rings and they have they had kept you for long. Now people from the dormitories, they want to pass through those small corridors, 100 of them. If you were to pass through that corridor, when you were just like 100 boys passing through a single corridor to the DH, imagine. So the smaller that corridor, people will pass there with difficulty. So the smaller corridor represents the other small, the thin conductor. That if the wires are thin, the electrons will not flow well. But if the wire is big, like for example, if those corridors were large enough, some people will even just be running as if they are in a pitch, doing cross country, no, anyway, in the road running for cross country. So that corridors which are big will enable more boys to run into the kitchen. I'm using boys because I was once a high school boy. That time, anyway, it is just something to bring about the other difficulty of electrons to pass through a small, anyway, electron is flowing through a small and a large surface area conductor. So when when they are transmitting those high energy cables or high electricity cables, they use thick because they don't want electricity to be having difficulty in flowing. They don't want the current to have that difficulty. That difficulty is the resistance. So reduce the resistance by increasing, reduce the resistance by increasing the surface area, the cross-sectional area of a conductor. Then that is it. I don't know, since we are approaching, we are already at 6. We are 6 minutes late. I don't know from Mr. Kaziba, what is your view maybe? Because I wanted at least to talk about only part C, D, E, F. We finish this item and then we call it the time. Mr. Kaziba, are you online? Okay. As Mr. Kaziba is coming back, to those people who are to go for lunch and to those people who are to go for those Sunday scholars, you may go home, please, because if we exceed, if we go beyond too further, it will be late for you. So if they have called you for supper, you can go. If it is time to go home, please. For the day scholars, I think we can just stop from there. The question is, are they with your teachers? We shared them on WhatsApp. So you will be discussing them. So as we proceed to part C, as we proceed to part C, determine the current in the house if, let me just remove this annotation. So if we can determine the current in the house if 20% of the electrical energy is lost during the voltage change, please, Gundi, talk about that power loss. The power loss, you will cater for it as you are determining the current in the house. So you talk about that energy loss of 20%, please, as you are discussing there, put that in emphasis. Then account for the energy losses, that is part D, account for the energy losses as the voltage changes and how these losses can be reduced. So accounting for the energy losses as the voltage changes and how these losses can be reduced. The knowledge should be to the transformers, Remember, in the transformers, as in we take it to be ideal transformers, but it is difficult for the transformer to be ideal, that it works 100, it is 100% efficient. It can't be. So being not ideal, then it means that there have to be energy losses in that transformer. So accounting for it, it has to be, why do you think those energy losses are there in the transformer? So please, as you are explaining to the learners, please use the knowledge of physics to explain to the learners. Knowledge of physics to explain to the learners. Then, to account for the energy losses, then, as you are explaining to them, it shows some maturity as you are directing your explanation, that you are talking to these learners. You are telling the learners, but as you are telling those confused learners, don't elaborate more. You should not elaborate more as you are doing it. Please, as you are explaining or giving the explanations of voltage change, be on point. You are telling the learners, but also don't forget that we want the physics in it. So don't say that you don't elaborate more. You have to be on point, but in line to giving explanation to these learners. Then also help the learners to understand how the current used in the TV is changed from alternating current to direct current. Then this one also comes. Part E, to understand how the current used in the TV. Remember, there is an information from the statement that, where is it? The house has 2 televisions. The house has 2 television sets that operate on direct current, but should be connected such that they receive maximum current and function properly. Remember, the transformers use alternating current. They operate on alternating current, not direct current. Now, as they step down the alternating current into the house, that alternating current have to be used by the television sets. But these television sets use direct current. So understand how the current used to TV is changed from alternating current to direct current. So I think someone has thought of something. So what enables direct current? How do they convert direct current to from alternating current to direct current? So which knowledge is there? Which understanding is there that you draw from the knowledge of electricity and magnetism that draws to converting the alternating current to direct current? Because if you just do the transformers, they just step down in the alternating current. So as they step down in the alternating current, that alternating current cannot be used in the TV sets. So in the TV sets, we have to use direct current. How is it converted? Here we move to Central College Kawala. Are you there? Central College Kawala? Central College Kawala? Please, as if your video and audio are not active, then let me look at, hello, please. Help me with that noise from, just close that window, that door. That noise is bad. Let me go to Madu SS. Madu SS. This chance has come to you, Madu SS. Madu SS. Madu SS.
By using a diode.
By using a diode. Thank you so much. by using a diode. Thank you so much. As they use that diode, Madu SS, may you proceed?
As they use that diode in a set, it converts AC to DC.
Which process is that?
That is passing alternating current direct into a diode network.
Okay, thank you so much. Thank you so much. They use diodes in converting alternating current to direct current. That is so good. Thank you so much. A representative at SS, but your network is also not good. Let me give another one to talk about it. Let me look at Namungona Parents SS. Are you there? Namungona Parents SS. How is it alternating current converted to direct current?
Alternating current is converted to direct current by rectification using a 4-diode rectification.
Thank you so much. Thank you so much. Rectification, that's a process. Diodes are used. May you please mute? Namungona, may you please mute? Thank you so much. So, diodes can be used in other ways, but for the case of converting alternating current to direct current, that is a process of, that is rectification. So those ones who have covered something in about rectification and those ones who have not, please, I want you to go expound more on how those rectifier circuits are designed to make sure that alternating current is converted to direct current. And also, you have to talk about how the two forms of direct current are produced. That is the full wave and the half wave rectification. So don't leave the knowledge of having them in your mind on learning how they work and how they design to produce a full wave rectification and half wave rectification. When is the full wave rectification produced and how is the full wave rectification produced? So those people who have not yet covered it, don't worry. We still have some time, and please do a research. Those things are not so difficult. So you can go to the libraries, you go to the internet, they show you how rectification occurs and how it is done. Someone from Notre Dame High School, I'm coming to you. So be online and be ready to this next requirement. Is Mr. Kaziba, are you online? Are you back, sir? Hello, Mr. Kaziba? Okay. But please. Yes, please, Mr. Kaziba.
Yes.
As if I'm too late.
Oh, can we just answer a few questions, maybe two?
From there?
Yes.
Okay.
I'm seeing very many hands up.
Okay. Okay, if there is any question, please, we are back to you. Let me just get someone from Lugashari Parents. Lugashari Parents Kagadi. Lugashari Parents. May you please unmute if you have any question for anyone who has a question.
How can you install the
Yes,
transformer?
The transformer?
How can you install the transformer?
How can you explain the transformer?
Install.
The question is,
yes,
how can you install the transformer?
Is it no noise or what? Please don't cause noise when someone is
How to install the transformer?
the knowledge of this transformer.
Yes.
Okay. Now with the transformer is in electromagnetic induction. Now, when you are explaining the transformer, just talk about the process of induction. How induction occurs? How induction occurs? But let me try to share something about it. Then we talk about how induction occurs because we are just in that part of electromagnetic induction in the transformer. How is current from the primary coil and the coil? Okay, because there isn't anything. So as you are talking about the transformer, may you please mute? Let me mute them. As we are talking about the transformer, our emphasis is put on how does electromagnetic induction occur in it. So the occurrence of electromagnetic induction is about two coils, the primary and the secondary coil. So as we are here, let me try to look for something I can share with you such that I just display it I display it in the shared screen such that you see where you are going to put emphasis. Where you are. Let me just see. Let me just make sure that I share for you what you want. See it. Okay.
Yes, I'm trying to see whether teacher self is getting back. It seems I'm losing out on him, but I'm seeing very many hands up.
Yes.
I'm seeing very many. Okay. Teacher Sebofu?
Yes, please.
Okay, you are back. You are back.
I'm trying to, what I want is to show these people where exactly they should emphasize in explaining the operation of a transformer. Because someone hearing what a transformer is, then where should they put their emphasis? So I want to do it such that we show them and they get the good direction. Let me just see facilitation. This is it. Get you see, because when I just go into annotation, then to be wasted, we shall waste a lot of time. Waste a lot of time. Not this here. Where is? Resistant magnetism.
Mr. Self, is it failing?
It has failed to come well because I'm not from my source where the transformer.
Maybe we can leave it. We shall share with them.
Okay.
After the session.
Okay, then we get some others.
Yeah, we get one more. One more from
Yes.
Notary. I don't know. I think I was seeing Notary Academy.
It is no. From I have some.
There's something loading. I'm seeing the white screen.
Yes, please.
I was seeing the white screen trying to come, but I think let us just pick one.
We pick one. Let me get someone from Notre Dame High School. Notre Dame, are you online? Notre Dame High School. Yes,
Yeah.
Notre Dame.
Good evening.
Good evening.
Our question is about what are the advantages of using SC over DC?
The advantages of using SC over DC. That is it. What are the advantages of using SC over DC? Okay. Responding to that question, let me first also get something somewhere else from these learners. Let me look at if you had raised the hand for a question, I'm sorry, but let me also pose this to you. Those ones, a question from Notre Dame. What are the advantages of using SC over DC? Please, as you were there, that is our last question, but please, we want to expound more of it. SC over DC, let me look at St. Francis Xavier Modern School. Do you have some response about that? St. Francis Xavier Modern School. St. Francis Xavier. St. Francis, you're not there. Then let us talk, let's try. I'm sorry for that, but I want at least to get contributions from the learners, because if I just pop it to you like that, it means that I'm just encouraging you to be depending on me. But let's get something from, let us get someone from ACT High School. ACT High School, can you please help us in that? ACT High School. You are not there. Then, okay. The advantages of SC over DC. One, if it is, let's talk about, let us give this experience. Have you ever, when you are to recharge something, let's say a battery or what? Recharging batteries would require someone to be if it is recharging batteries, anyway, recharging batteries, it is a DC. If you are to recharge a battery, you get a DC source. But it has to be, for SC, it is that it can be transported to higher, not transported, but transmitted with in high distances, it cannot maybe yield, that is, power losses along the transmission line. So SC electricity or SC electricity can be transmitted to higher destinations or along higher power lines, long power lines than DC. DC cannot be transmitted longer. It cannot be transmitted longer. So there can be too much power losses when you transmit DC in long power cables. So with SC, it can easily be transmitted longer distances, but DC, it cannot be. Then also, another advantage of AC over DC, that the process of change of cycles, it is quite difficult for an SC, may I say, the difficulty in let me first look at this. Oh, sorry for that. Some network problem here. Anyway, Mr. Kaziba, are you on? Advantages of SC over DC. Central College Kawa. Let me just look at this. Godisway High School. Julius, Acacia Girls. So now with advantages, let's go directly. It is that the DC system, the SC system, the storage is DC, because DC can be stored for a long time. Then what should be done there? Let me see here. Over DC transmission. That's it. Okay. Alternating current, the other one can be transmitted for longer distances. That is fine. Then also generating DC, generating DC is quite difficult than generating SC. With generating DC, it is quite difficult than generating SC, because this is quite complicated with its generation, because you have and when you just lose it, you lose it for long, for all, losing DC and SC. You can just use SC continuously, but with DC, it can be just used up. So as you are using DC, use it for some time, then it gets used up. But the SC sources can be just used continuously. Like for example, the power dams. For the power dams, they just generate SC. As they generate SC with batteries, you use DC for long and it finishes. Then this, you just need to redo it, but the SC can be used continuously like that. Then also, there is the polarity of SC. Polarity that as the SC changes the poles, the terminals, or remember, as SC is in the line, it just does the positive changes with the negative and positive changes with time. It does not do what? It does not have a constant terminal that this is positive and this is negative. So the way it changes, it is difficult for you to make a short circuit of when you are using SC in a connection. But when you are connecting DC, the DC source, if it is the DC, if we were connecting, for example, a load like a bulb, the positive has to be connected to a positive, and a negative has to be connected to a negative. So as you are connecting the DC, you cannot connect, if in case you connect a negative to a positive, the load to which you are connecting it will get a problem, there will be short circuit in it. But with SC, being that it changes positive to negative and negative to positive with time, as it cannot be there for long. So the polarity changes from positive, negative, negative to positive. So in that, it means that even if it is easier to connect a load, like for example, in your homes, have you ever been, for example, those ones who are connecting chargers to sockets to umeme, have you ever minded about poor connection when you are inserting a plug of a charger to the socket of the socket at your home? You just plug it there. You have never thought of like which one is positive, which one is negative. So there is no difficulty in connecting SC. You just connect there and then, and the load will start working, because the polarity, the terminals change. They don't just be constant, or they are not fixed that this terminal is positive, this terminal is negative. That is it. So what I can talk about is about the changing polarity of SC, and also the transmission, that DC cannot be transmitted for longer distances. DC cannot be transmitted for longer distances. Then maybe someone else can give some other contribution, or you can go to the internet and finish it. You get other sources. Thank you so much.
Mr. Ronald.
Yes,
I
please.
feel we may not be able to go any further. These children may miss out their supper, but allow me to first thank you so much for the wonderful session you have been able to offer. I've loved the way you have been able to simplify physics. Thank you so much. I do believe that all the children here have been able to get something from the session. Now for the schools, I am seeing you still have more questions, but we are going to plan better and see how next week we shall be able to do something, probably in physics again, such that we can be able to handle. But the good thing, in the holiday, we are able to handle something on practical. We shall reshare that link such that you can be able to revisit. But I want to thank all the schools that have joined in. Thank you so much. I saw Mr. Ronald. Mr. Ronald, kindly unmute if you are in position. Yes.
Let me pack Mr. Kaziba. I don't know if you can hear me.
Yes, you are very clear.
Okay, good evening, dear students and teachers. I must say I'm lucky to have met you online. I've been in a meeting the whole day, and I just tried to check to see if this link is still active. And that tells me that my teacher there is very committed to making sure that we all succeed. But I also want to thank the administration that has enabled you to join in. I have seen schools from very far, and this is what we call closing the learning gap. We just need to continue working together. We will always provide teachers to support you because we want you to excel. And when you excel, please come back to your schools and support your schools with the knowledge you have gained. I want to thank Mr. Kaziba and your team for organizing this. And I know that we shall continue organizing more sessions to support these candidates before they get into the final exams. Thank you all, and I wish you a good evening. Thank you.
Thank you so much, Mr. Ronald. Thank you so much, everyone. We shall end here and let's meet tomorrow for English. Have a good evening.